In today's video, we're going to learn the differences between theoretical and experimental probability. By the time you're finished watching this video, you will be able to define, compute, and compare experimental and theoretical probabilities. Let's begin with some definitions. The theoretical probability is based on knowing and calculating all of the equally likely outcomes of an experiment. In other words, it's what should happen. Just like its name says, theoretical. Theoretically, if I flip a coin, I have a 50-50 chance of getting either heads or tails. The way we compute the theoretical probability is that we take the number of favorable outcomes and divide it by the number of possible outcomes. Or we can simply say we're forming a ratio of the number of favorable outcomes to the number of possible outcomes. Using our coin toss as our first example, let's look at the theoretical probability that we will land on tails. I've already said that it's 1 out of 2 or 50%, but let's look at why. So we know the probability of any event, and I'm going to abbreviate landing tails as just a lowercase t. The probability of getting tails, if we flip a coin, there's only one way you can get tails if you flip a coin. So that is the number of favorable outcomes. And we're going to divide that by the number of possible outcomes. And if you flip a coin, you got two possibilities. It's going to be either heads or tails. So the probability of getting tails, the theoretical probability, is 1/2, or 50%. There's a 50% chance that if you flip it, it will land on tails. Let's look at another theoretical situation. What if we flip the coin 20 times? How often should we land on tails? Well, if the probability of getting tails is 50%, then in order to find the number of times we would get tails for 20 times, we would find 50% of 20, which is 10, half of 20. So theoretically, if we flip our coin 20 times, then we would get tails 10 of those times. For an interesting experiment, take a coin and flip it 20 times and record how many times you get tails. How did it compare to what you theoretically thought? Did you get it 50% of the time? Experimental probability, on the other hand, is based on actual repeated trials of an experiment. It's what actually happens. All right, so let's look at experimental probability at work. Let's see what happens if we flip a coin 20 times. If the probability of getting tails is 50%, theoretically it would be 10, but let's see what happens in real life. Now, to make this thing go a little bit more quickly, we're not going to flip one coin 20 times, we're going to flip 20 coins. All right, there's our 20 coins, and start flipping now. Let's flip them. Let's just get them flipped. All right. Now let's kind of put them all in the middle so I can get them close and we can count what we've got. Okay, here's all of our coins. Okay, now let's circle all of the ones that are in tails. And I know that with this lighting, it's a little bit hard, so you might have to trust me on this. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. That is all of the ones that are on tails. Okay, so we had 9 tails and 11 heads. And if we do the experimental probability, okay, let's write this down here. Probability of tails. We had 9 actual tails over 20 possibilities, which is the same as 45%. The theoretical probability was 50%, so it was almost what we predicted it would be, but not exactly. And that gives you an example of theoretical versus experimental probability. Now that we know the difference between experimental and theoretical probability, let's see if we can look at a situation and determine whether or not it is a theoretical or an experimental situation. Let's look at the first example. I rolled a die 30 times and it landed with a 6 face up 10 times. This would be experimental. If you think about our definition of experimental probability, we are talking about what happened exactly. We actually rolled it 30 times. It actually landed with a 6 10 times. Number 2, 16 airheads in a bag, 4 are cherry, 7 are orange, 5 are apple. The probability of picking cherry is 1 out of 4, which is the same thing as 4 out of 16. This is what could happen, what might happen, what will theoretically happen. This did not actually happen, so this is theoretical. Let's look at another example of theoretical versus experimental probability. Instructions tell us to roll a die 20 times and record the outcomes. Now, in the effort of saving time, I've already rolled a die 20 times for us and recorded the results. And you can see here what the results of that are. We rolled a 1, 5 times. The 2 we rolled 3 times. 3 we rolled 4 times. 4 twice, rolled a 5 twice, and a 6 4 times. Now let's compare some theoretical and some experimental probabilities. Let's look at the probability of getting a 4. When we roll a die, there are 6 possibilities. Looking at our picture of a die, we see 3 of the sides, because it's a cube, so it has 6 sides. We can get a 1, a 2, a 3, a 4, a 5, or a 6. So theoretically, in order to get a 4, there is one way to get a 4, and there are 6 possibilities. So the theoretical probability of rolling a 4 is 1/6. Experimentally, let's look at what actually happened. We actually rolled a 4 2 times out of 20. So it was 2 out of 20, which let's reduce that to 1/10. If we try to compare this theoretical to experimental probability, 1 out of 6 is bigger than 1 out of 10. So theoretically, we should have gotten a 4 more times. Let's look at the probability of rolling an even number. Our even numbers are 2, 4, and 6. And if we add up their possibilities each time, experimentally, we had 3 plus 2 is 5, plus 4 is 9. So experimentally, we had 9 even numbers out of 20. But theoretically, we have 1, 2, 3 even numbers. That's how many possibilities we have out of 6 possibilities. And when we reduce that, or simplify this, we get 1/2. Now 9/20ths, as we compare our theoretical to our experimental probability, and that's pretty close because 10 is half of 20. So that was really, really close in this particular instance. Not the same, but it was pretty close. For our final comparison, let's look at the theoretical and experimental probabilities of rolling a factor of 3. Just as a reminder, a factor is a number you multiply. So the factors of 3 are the numbers you multiply to get 3. There's really only one way to do that, and that's 1 times 3. So 1 is a factor, we rolled it 5 times. 3 is a factor, we rolled it 4 times. So that was 9 out of 20 times. Our theoretical probability, we have 2 numbers to choose from, so 2 possible outcomes out of 6 total. Go ahead and reduce that to 1/3. And the experimental probability, we said there were 9 times that a factor of 3 were rolled out of 20 possibilities. If we look at 1/3 of 20, we can estimate that to be about 21, so be around 7. It's a little close, but it was not exact. You can see that in all of these cases, the experimental and the theoretical probabilities were not exact. Stop the video at this point, and you will see 5 more additional problems for you to do. Do those 5 problems, and then restart the video. Questions 4 and 5 on your note-taking sheet are discussion questions that we will discuss in class tomorrow. I will, however, take just a few minutes to show you the answers to 6, 7, and 8. Let's compute the probability of drawing a jack from a standard deck of cards. In case you're not familiar with what that means, over here to the right, these are the jacks. And there are 4 jacks total in a deck of cards, one for each one of the suits: hearts, spades, clubs, and diamonds. So theoretically, we have 4 possibilities to choose from. And a standard deck of cards has 52 cards to choose from. So the probability of pulling a jack is 4 out of 52, and let's reduce that. That would reduce to 1 over 13. The probability of rolling a composite number on a fair number cube. A fair number cube is the same thing as a die. 6 numbers, 1, 2, 3, 4, 5, and 6 on there. And composite numbers are numbers that are not prime. In other words, they have factors other than 1 in themselves. Well, on a fair number cube, the composite numbers are 4, 5, and 6. So there are 3 possibilities out of 6 total. So the probability of rolling a composite number on a fair number cube is 1/2. Last but not least, let's look at the probability of picking a vowel from the word mathematics. If we look at the letters in the words mathematics, there are 1, 2, 3, 4 vowels, 2 A's, 1 E, and an I. And there are 11 total letters in the word mathematics. So the probability of pulling a vowel from that word is 4 out of 11. So there's theoretical versus experimental probability. If you have any continued questions, be sure to go back and review this video.